Let us find all the real number x such that 9 to the power x plus 33 to the power x equal to 121 to the power x. You see that we have different bases. Now, if base were same, maybe we could have compared the power, but you see that we don't have same base. Let's write the equation once again. 9 to the power x plus 33 to the power x equal to 121 to the power x. That can be written as, but 9 is 3 square, so 3 square to the power x. 33 can be written as 11 into 3 to the power x. 11 square is 121. Alright. Now we know that a to the power mn equal to a to the power m whole thing to the power n by law of indices. So we take a equal to 3, and so we can write it as 3 to the power 2x plus, here we can write that ab, here we can use the identity that ab to the power m equal to a to the power m into b to the power m. So this is equal to 11 to the power x into 3 to the power x equal to, here again a to the power mn equal to a to the power m into a to the power n, so 11 to the power 2x. Now we see that similar numbers exist, 11 and 3, but still we are not able to compare the left hand side and right hand side. Now let's write it further. We can write it as, okay, let's divide by 3 to the power 2x. Dividing. So what we do is we divide this equation throughout by 3 to the power x into 3 to the power x. That's 3 to the power 2x. So we write the equation once again. 3 to the power 2x plus 11 to the power x into 3 to the power x equal to 11 to the power 2x. So we are dividing by 3 to the power x. Let's do it. 3 to the power 2x. This one 3 to the power x into 3 to the power x. That's 3 to the power 2x. And this one 3 to the power 2x. Now we see that 3 to the power 2x gets cancelled here. So that implies 1 equal to, again 3 to the power x gets cancelled. 1 plus 11 by 3 to the power x. That's equal to 11 to the power x by 3 to the power x, again by law of indices. Here 11 by 3 to the power 2x. Wow, we see something that we can handle now. Let's take everything to the right hand side. So 0 equal to 11 by 3 to the power 2x minus 11 by 3 to the power x minus 1. So again we write this as 11 by 3 to the power x whole thing square by law of indices. A to the power mn equal to a to the power m into a to the power n minus 11 by 3 to the power x as it is minus 1 equal to 0 as it is. Now we have something like quadratic equation. If we let 11 by 3 to the power x equal to y. Now if we let that, then we have a simple equation, as we can see that y square minus y minus 1 equal to 0. This is a quadratic equation. We recall what exactly quadratic equation is. Ax square plus bx plus c equal to 0. Here if we compare a equal to 1, b equal to minus 1 and c equal to minus 1. Roots are given by x equal to, but we have quadratic equation in y, so we write y equal to minus b, so minus of minus 1 plus minus root over b squared, so minus 1 whole thing square, b equal to minus 1, minus 4 into a is 1 and c is minus 1 divided by 2a, a is 1. That's equal to 1 plus minus root over 4 plus 1 is 5, root 5 by 2. But y equal to 11 by 3 to the power x. Therefore, we can write 11 by 3 to the power x equal to 1 plus root 5 by 2 or 1 minus root 5 by 2. Now you see that 11 by 3 to the power x is positive quantity, so we reject this number. We will restrict to real number only, so we reject it. So we write 11 by 3 whole thing to the power x equal to 1 plus root 5 by 2. Now we take logarithm both side. So log of 11 by 3 to the power x equal to log of 1 plus root 5 by 2. Now power we can write outside of the logarithm. So x into log of 11 by 3 equal to log of 1 plus root 5 by 2. Lastly, we can simply write x equal to log of 1 plus root 5 by 2 divided by log of 11 by 3, and we are done.